Okay, science, I have everything I need. I have my data table, I have my hot water, my timer, and one Alka Seltzer tablet. And I took 200 milliliters of water. Actually, it's 225 milliliters of water. And I put it in the microwave for 1 minute. It's pretty warm, so if you're using really warm water, please be careful. I'm going to take my Alka Seltzer tablet, drop it in, and start the timer as soon as it hits the water. Do you think a chemical or a physical change is happening? As soon as it stops dissolving, the bubbles stop being produced. I'm going to stop my timer. 22 seconds. So I'm going to record my data in my table here. Label my number, 22 seconds. And I'm going to do this trial 2 more times. If you're in the classroom, you may just do it 1 time and then record the data from 2 other groups. So 3 trials total. I'm going to stop this video. I'm going to go ahead and do my other 2 trials, and then I will share my data. Okay, scientists, I finished my 3 trials of my hot water. As you can see, the second trial I recorded 21 seconds for dissolving, and the third trial was 22 seconds for dissolving. So now I have cold water that I took out of the refrigerator, and I filled my graduated cylinder back up to 225 milliliters. Remember, however much water you use for your first set of trials, use the same amount of water for your second set of trials, whether it's 100 milliliters of water, 500 milliliters of water. Remember, the only thing we're changing is the temperature of the water, so everything else has to stay the same. Also, consider your Alka Seltzer tablets. If you have some that are broken, that could affect possibly how fast it dissolves. So make sure you're using whole tablets as well. Okay, cold water. We're going to get ready, drop it in. Using my observational skills, it didn't seem to start fizzing as quickly. Those bubbles represent a gas being produced. Now typically, what do you see happening? We're already at 32 seconds, and to me it looks like it's not even halfway dissolved yet. It's moving around. It's over here right now. Can you hear the bubbles? Again, is this a physical or chemical change? I'm thinking that already you're reflecting on your prediction. Does the temperature of water affect the amount of time it takes for an antacid tablet to dissolve? Do you think you already have the answer? Well, don't be too sure with 1 trial. Remember, we're going to do 3 trials. As I'm looking at the side, it's breaking apart. I don't want to jostle the graduated cylinder, or the beaker, as that could possibly affect it somehow. So I'm just leaving it still, but I'm looking along the side of it. Oh, it's getting close. You may be able to see that less bubbles are being produced. They're still being produced though. Slowly but surely. Still some I know to stop my timer when the bubbles stop being produced. Oh, stop. 2:25. Now, one quick bit of information. We recorded in seconds. I want to convert this time to seconds because if I add a 2, that's 2 minutes, or I'm looking at seconds here. So I need to do a little math. So I know that 1 minute is 60 seconds. A second minute is 60 seconds. And then I have 25 seconds. So I'm going to add all that up. And I have 145 seconds. So I'm going to record that right here. Okay, so I'm going to go get my water back out of the refrigerator. I'm going to do my other 2 trials and record that data. I will post my completed data table in the Nearpod so you can see the results of the other 2, because then we'll need to discuss the results and how was this affected by the temperature of water.